you mentioned this data scientists predicting essentially the business outcomes using models. And one thing that came to my mind was Zillow, right? They basically did that. They used machine learning models to essentially project or essentially guide their business strategy. And that led to the acquisitions of loads of homes at a very high valuation, but it backfired, right? Is there such a thing as over reliance on the strategies that are basically coming out of processes from AI?
The missing component there was the reliability requirement. And that's something, I ended up writing what happened and what went wrong with Zillow. What went wrong there is they were using more descriptive modeling when prescriptive modeling and predictive modeling, which is what they needed, has a higher reliability requirement. So what was interesting is the C-suite articulated, we have this very narrow range where if we don't hit this sweet spot, we won't make money. They articulated that to the data science team, and then somehow the models that got delivered weren't delivered with the message of, yeah, this is probably not going to meet that threshold of reliability requirements.
Mm.
And so if you don't have that alignment where senior leadership articulates a reliability requirement and is able to understand the models well enough that are being presented to say, this doesn't meet our reliability requirement, that's where you have a danger, is where you have that disconnect, because traditional data science and machine learning without a research cycle cannot produce anything that is reliable enough to do exactly what Zillow was trying to do. And that's, the danger is that companies don't get advertised. Like there's no big flashing sign that says, hey, you've gone from descriptive models are going to work really, really well to you need a higher level of evidence to support any model that you have now. And Zillow just ran past that line without coming to terms with the amount of investment it would take to build out a research team and to actually do the experimentation required to build a body of evidence to support their model's functionality, the model's inference. They didn't do any of that. And so that was the disconnect, is if you go from, yes, describing what's happening now and then just extending that trend line out is enough, to now we're putting a business model around this, it better work. It needs to be far more reliable. And if you cross that line without being intentional and having people on staff who understand what it takes to actually do predictive modeling and prescriptive modeling, if you don't have people on staff that understand the difference, you're in the danger zone. I mean, that's really where a lot of businesses are finding themselves right now. They're overextending their data, they're overextending their data science capabilities, and they don't have anyone there to sound the alarm.
Mm. So I want to sort of dive into this descriptive modeling. Firstly, what does it really mean? Because I would assume that taking a predictive modeling approach or any modeling approach is using past data to infer future results. What is descriptive modeling?
So what you're talking about is essentially a type of experiment. It's an observational experiment. That's what we do for a living as data scientists. But if we don't advertise the limitations of an observational experiment, we're in a lot of trouble. When you build a machine learning model, you got to dive down into what is that really. Most machine learning models, I call them hypotheses, because what a machine learning model does at first is it's just a transformation of the data. That's all it is. The inference is just basically a SQL query. If you don't do your modeling with any more rigor than just, you import your data frame, you train, test, validate, and then you ship it. That doesn't work. That's a descriptive model because it's just a transformation of the data. Like I said, it's a really expensive SQL query.
Mm.
And so that has value though. That's not valueless. Businesses, if you have a person who understands, who has the data literacy to understand that this is just telling me what's happening right now and giving me a very advanced view of what's happening right now. And it allows me to explore the data. And that's what a great machine learning model does, is it allows a user to explore the data in a far more user-friendly and straightforward way than they would really with any other approach. And so that's the great power of a descriptive model, but we don't advertise it that way enough. Most of our field says import data, train, test, validate, ship it. And that's a reliable model because here's my whatever accuracy metric. What? That's insanity. And we have to back away from that approach because we've just overextended data. If we say this can predict anything, it can't. It's just a reflection of the data. There's nothing beyond that. But it's a great hypothesis. That's the wonderful thing about models is they can propose things that are based on complex relationships within the data. It can propose ideas or frameworks for us to evaluate as people. But there's another step. If we want to say this framework is accurate and the inference will hold over time, you got to do more. You can't just ship it. That's not going to work. And that's what I mean by there's that cliff. When you go from this is a great exploratory data tool to I'm shipping this to production, it's going to run, and we're going to put a business model on top of it. I don't care how big your data set is. I don't care how advanced your train, test, and validation processes are. I don't care how many models you've evaluated against each other. You can't do that. You don't have any evidence. And so you have to then rely on more rigorous observational studies. Eventually, you have to go into more rigorous experimental methods. You have to continue to validate and create a body of evidence for the inference that's being served. You're validating your hypothesis and you're looking for, once you get into causal logic and causal methodologies, you begin to look for and evaluate counterfactuals. You begin to look for causal relationships between variables to truly understand the system that you're modeling. And that's where we get lost is there's a gap between basic data science and your more rigorous processes, the research lifecycle that will actually create a body of evidence to support that this model will fold. And if you talk to hard sciences people, they hate data scientists because we ship stuff that doesn't work and we pretend it does. And that just infuriates hard sciences groups who have been doing this forever and who are held to a ridiculously higher standard than we are. But yet we get all the business investment, we get all the interest, we got all the hype. And it's funny because there's only about 10% of us that talk about data science in this 3-tiered, where you've got descriptive, predictive, prescriptive, and each one has an increasingly high level. And I would say it's like a log scale. It's not like, it's not linearly more evidence. I mean, it's significantly more evidence to support the fact that your models actually found something, that it works, that some small data drift isn't going to send it off the rails. So there's just so much more that you have to do in order to support models doing anything aside from allowing people to interact with their data in an easier, more straightforward way.